Hello everyone, my name is Boyang Qi, and today I will present our research plan, IoT architecture for real-time edge and cloud collaborations. At first, I will introduce our team member real quick. They are Zhelian Qi, Rinbo Zhou, Yun Zhang, Heng Xu, and myself. And the submission will be 19th of August 2025. So first, let's go through our agenda real quick. I will introduce our motivation and objectives first, and then get into our key design of our architecture and the methods, and then we will go through the evaluations and the whole project timeline. So first, our research purpose is to design a scalable perception edge and cloud architecture which can develop adaptive task allocation and routing. And then we will try to validate via our simulation results or prototype. So first, let's go through our design system real quick. So first, I want to introduce you our perception side. So at a perception, at a high level, the sensors and tiny ML MCUs perform denoising, feature extraction, and privacy masking. For the edge nodes, they execute low latency interference, short-term caching, and the cloud service run on a containerized infrastructure for global aggregation with a heavy model training and policy distribution. So the data flows are event-driven. Urgent events go to the edge immediately. Lower priority data can be batched and uploaded to the cloud. And now I'll introduce our key innovations which are used in our design. So first, we set up a clear layer responsibilities. So for the perception layer, the devices there are low power sensors or some tiny ML enable microcontrollers. Their task is just sample noise, extraction, compact features, mask private information, and raise local alerts. The aim is to reduce uplink volume while preserving the information necessary for immediate decisions. And our second layer is edge. Edge nodes provides low latency interference and short-term buffering. They act as the first decision point, filter false alarms, run log-weight models, and trigger accurates. They also implement resident strategies like local rollback, catch and forward, or like dynamic task migration when the system is overloaded. And our third layer is our cloud service. It performs long-term storage, heavy model training, cross-site analytic, and global scheduling. It performs on offline model updates. It can aggregates edge statistics and distributes improved models back to edge. The cloud is not in a fast control loop. This role is to coordinate and continue learning. So our methods to realize our plan. So first, our algorithm approach combines multiple agent reinforcement learning for dynamic task allocation, and plus with the rule-based heuristic. And then our data routing prioritized event-driven uploads and compresses batch batch low priority data. We formulate the system objectives as constraint optimization, balancing, which balance the latency throughout throughput and energy consumption. So we set some target that which our systems can reach. So the first one is the latency. It will be no more than 30 milliseconds. And the second is our throughput, which is definitely larger than 1 million events per second. And third is our edge utilizations, which will be larger than 80%. So that's three key data or target that we need to reach by using our system. And then I will introduce you our evaluation plan. So first, we will use some simulation tools like iFogSim or Edge Cloud Sim to simulate our to get a simulated result for our design system. And then we will use some prototype the softwares like Jetson or AWS, and maybe we will introduce a Promise series to monitoring our system's performance. And at the end, I would like to make a brief timeline plan for our project. So for the first 3 months, we will do some literature and requirements surveys to know that our directions and what else like the previous work has done. And then we will use like 2 months to design our architecture and algorithm. Then we will do the simulations to check our system's performance. And after that, we'll do prototype build, integration, and testing. After 30 months of all that, we will use like another 2 months or 3 months to write a paper and release our results. So that's all. Thanks.